The United States created a weapon so strong it doesn't need explosives, just raw speed and metal. The Navy's over $200 million railgun fires solid steel at over 8,000 feet per second, tearing through ships like paper from nearly 100 m away. But after years of jaw-dropping tests, this terrifying machine vanished. Why did the Navy suddenly shut down its most powerful weapon? And what secret danger forced them to walk away? Join us as the United States tests its railgun worth millions. The metal beast sits motionless on the testing platform, its twin rails gleaming under the harsh lights of the Naval Surface Warfare Center. This is no ordinary weapon. The electromagnetic railgun represents 15 years of military engineering and $500 million in taxpayer money. Its sleek barrel stretches forward like a cannon from the future. But inside, pure science replaces gunpowder and explosives. When the countdown reaches 0, invisible forces unleash their fury. Electromagnetic fields generated by massive electrical currents grab hold of a 7 pb projectile and accelerate it down those parallel rails. The speed builds instantly, faster than any traditional bullet, faster than most missiles. In less than a second, the projectile screams out of the barrel at 8,270 feet per second. That's more than 5 times faster than a rifle bullet. The destructive mathematics is terrifying. This projectile carries no explosives, no warhead, and no chemical energy. It doesn't need them. At hypersonic speeds, kinetic energy becomes a weapon. The faster something moves, the more devastating its impact. When a 7-pound chunk of metal strikes a target at these velocities, it delivers the same destructive force as a small artillery shell packed with high explosives. Navy engineers pushed their creation even further during years of testing. Early demonstrations showcase an 8 megajoule system firing projectiles with incredible precision. But the real monster was still coming. A planned 64 megajoule weapon system designed specifically for warships. The power requirements were staggering. Each shot would demand the same electrical energy that powers several city blocks. The weapon's range capabilities redefine naval warfare possibilities. Traditional ship cannons reach maybe 15 miles on a good day. The railgun could strike targets 100 miles away with pinpoint accuracy. Enemy ships, coastal installations, even aircraft. Nothing within that massive radius would be safe from this electromagnetic hammer. Testing footage reveals the weapon's raw power. Each firing sequence begins with a low hum as capacitors charged with millions of volts. Then comes a moment of release. A brilliant flash, a thunderous crack, and the projectile vanishes into the distance faster than the human eye can track. The ocean becomes the only safe backdrop for these demonstrations. No military installation days test this weapon anywhere near populated areas. The implications terrified and excited military planners in equal measure. Ships equipped with railguns could engage multiple targets simultaneously without worrying about ammunition storage or explosive safety. Traditional naval guns require tons of volatile gunpowder stored deep within a ship's hull, a floating bomb waiting for enemy fire to ignite it. Railguns eliminate that vulnerability. But the electromagnetic monster demanded a price that even the world's most powerful navy couldn't pay. The electrical requirements pushed ship power systems beyond their limits. Each shot drained enough energy to power a small town. The rails themselves wore out after relatively few firings, requiring constant replacement and maintenance. Heat buildup threatened to melt the weapon's core components. By 2021, reality overtook ambition. The Navy quietly shifted funding away from railgun development, focusing instead on hypersonic missiles and laser weapons. The electromagnetic beast that once promised to revolutionize naval combat became a $500 million lesson in the gap between theoretical possibility and practical deployment. But while America's electromagnetic dreams crumbled, another science fiction weapon was quietly proving its deadly potential. Could invisible beams of light become the Navy's ultimate defense? The USS Portland cuts through Pacific waters on May 16, 2020. Its crew preparing for a test that would make naval history. High above the ship, a small drone buzzes through the morning air, unaware it's about to become the target of humanity's first operational laser weapon system at sea. The laser weapon system demonstrator sits mounted on the ship's deck like a sleek telescope pointed at the sky. Inside its housing, solid-state laser diodes generate an invisible beam of concentrated light energy. Unlike the railgun's brute force approach, this weapon kills with precision and silence. No projectiles, No explosions, no ammunition to reload, just pure energy traveling at the speed of light. The targeting sequence begins as radar operators lock onto the drone's position. Computer systems calculate flight path, speed, and distance in milliseconds. The laser weapon swivels smoothly, tracking its target with mechanical precision. Then comes the moment that changes everything. The invisible beam reaches out across the sky and touches the drone. What happens next defies traditional warfare expectations. The drone doesn't explode in a dramatic fireball. Instead, its electronic systems simply die. Critical components overheat and fail as the laser's energy overwhelms delicate circuits. Within seconds, the unmanned aircraft tumbles from the sky like a broken toy, its threat neutralized without a single conventional weapon fired. The successful test sends shockwaves through military circles worldwide. For decades, science fiction promised laser weapons that could defend ships from incoming threats. The Portland's demonstration proves that the future has arrived. The solid-state laser system can engage multiple targets simultaneously, switching between threats faster than any human gunner could track them. Navy officials release carefully worded statements about the test success, but the implications speak louder than any press release. Enemy drones, small boats, and even incoming missiles now face a defensive system that operates at light speed. Traditional countermeasures become useless against a weapon that strikes instantly across vast distances. The laser's versatility extends far beyond anti-aircraft duties. Small attack boats, the kind used by terrorist organizations and rogue nations, become sitting ducks against this technology. The beam can disable engines, destroy navigation equipment, or blind optical sensors without sinking the vessel entirely. This precision offers military commanders options beyond total destruction. Power requirements for laser weapons remain significant, but manageable compared to railguns. Modern warships generate enough electricity to operate these systems continuously without draining other critical functions. Heat management poses challenges, but engineers have developed cooling systems that keep the lasers operational during extended engagements. The cost advantages become clear quickly. Each laser shot costs roughly $1 in electricity. Compare that to million-dollar interceptor missiles traditionally used against aerial threats. A single laser weapon system can engage hundreds of targets for the price of one conventional missile intercept. International observers watch these developments with growing concern. Laser weapons represent a fundamental shift in naval power projection. Nations without access to this technology face obsolete fleets overnight. The balance of power at sea tilts decisively toward countries possessing these light-speed weapons. Military strategists recognize the broader implications immediately. Swarm attacks using dozens of cheap drones could previously overwhelm ship defenses through sheer numbers. Laser weapons flip that equation completely. Now expensive attack platforms become vulnerable to relatively inexpensive defensive systems that never run out of ammunition. While laser beams defend ships with light-speed precision, the Navy's most devastating weapons still rely on raw explosive power. But what happens when these 1,000-pound instruments of destruction need reloading in the middle of a battle? Deep in the missile compartments of Navy destroyers, ordnance crews prepare weapons that can reach targets over 1,000 miles away. The Tomahawk land attack missile sits secured in its vertical launch cell, a sleek white cylinder packed with enough explosive power to level city blocks. These cruise missiles represent the ultimate expression of long-range naval striking power. Each Tomahawk carries a sophisticated guidance system that uses terrain contour matching to navigate across vast distances. The missile flies low, hugging the Earth's surface to avoid enemy radar detection. Its jet engine pushes a weapon at subsonic speeds for hours, following pre-programmed routes loaded before launch. The Tomahawk's 1,000-mile reach transforms naval warfare strategy completely. Enemy targets that once felt safe hundreds of miles inland now face destruction from ships positioned far beyond the horizon. Coastal installations, command bunkers, and critical infrastructure all fall within this weapon's deadly embrace. 7 different variants of the missile provide commanders with options ranging from conventional explosives to specialized warheads designed for specific target types. Beneath the surface, submarines carry their own arsenal of destruction. The Mach 54 torpedo weighs over 1,000 pounds and packs enough Torpex explosive to crack a submarine's hull like an eggshell. Torpex, short for torpedo explosive, delivers 50% more destructive power than traditional TNT. These underwater assassins can track enemy submarines across distances of 10,000 yards. Their sonar guidance systems hunting prey through the ocean depths. Surface vessels launch these torpedoes from deck-mounted tubes, sending them racing through the water at speeds that give enemy submarines little time to react or escape. The Mach 54's advanced guidance system can distinguish between different types of underwater targets, ensuring it strikes the intended vessel rather than friendly forces operating in the same area. But the Navy's most dangerous moment comes not during combat, but during the deadly process of rearming these weapons at sea. In calm harbors, massive cranes lift 1,000-pound missiles into their launch cells with mechanical precision. At sea, however, the ocean's constant motion turns this routine operation into a life-threatening gamble. Waves roll beneath the ship's hull, causing the deck to pitch and sway unpredictably. Sailors must guide missiles weighing more than half a ton into narrow launch tubes while fighting against gravity and momentum. One wrong move, one moment of lost concentration, and crushing death becomes inevitable. The Navy removed shipboard cranes years ago after too many accidents proved the danger too great to accept. Today's tensions with Russia and China make at-sea rearming operations more likely than ever before. Extended deployments in contested waters mean ships may need to reload their weapons far from friendly ports. Ordnance crews train constantly for these scenarios, knowing their lives depend on perfect execution under impossible conditions. The process begins in darkness to avoid enemy observation. Sailors wearing safety harnesses work in teams using hand signals to communicate over the noise of wind and waves. Each missile must be lifted by human strength and mechanical winches, guided carefully into position while the ship rolls beneath their feet. Modern missiles like the Norwegian Naval strike missile add another layer of complexity to rearming operations. These weapons can engage both ships and land targets at ranges up to 345 miles. But their sophisticated electronics make them extremely sensitive to shock and impact during handling. Even with these devastating long-range weapons loaded and ready, enemy missiles can still penetrate deep into battle zones. So, what happens when hostile projectiles break through and target the ships themselves? Modern naval warfare operates on a simple principle. Multiple layers of defense must work together or the ship dies. When enemy missiles streak toward American warships at supersonic speeds, commanders have only minutes to deploy countermeasures that mean the difference between survival and destruction. The first line of defense begins hundreds of miles from the target ship. Norwegian naval strike missiles mounted on Allied vessels reach out across 345 miles of ocean to eliminate enemy launch platforms before they can fire. These precision weapons use advanced guidance systems to track moving targets across vast distances, striking enemy ships with devastating accuracy. Each naval strike missile carries enough explosive power to cripple or sink most enemy vessels with a single hit. The weapon's sophisticated targeting system can distinguish between different ship types, prioritizing high-value targets like aircraft carriers and command vessels. When multiple missiles launch simultaneously, they coordinate their attacks to overwhelm enemy defenses through synchronized strikes. As threats move closer, the second defensive layer activates. HIMARS rocket systems, traditionally designed for land-based artillery, have been adapted for ship-to-shore bombardment operations. These versatile launchers can fire multiple types of projectiles from precision-guided rockets to long-range tactical missiles. The M142 high-mobility artillery rocket system proves its worth when enemy forces attempt amphibious landings or coastal bombardment. Each HIMARS pod contains 6 guided rockets or larger tactical missiles capable of striking targets with pinpoint accuracy. The system's rapid-fire capability allows ships to saturate enemy positions with devastating firepower in minutes. But the most critical moments come when enemy missiles penetrate these outer defenses and race toward their targets at speeds exceeding the sound barrier. Ship-based radar systems track incoming threats while computers calculate impact trajectories in engagement windows. Seconds count as a final layer of defense prepares to engage. The Phalanx close-in weapon system represents the last hope for survival. This automated defense system combines sophisticated radar tracking with a 6-barrel Gatling cannon capable of firing 4,500 rounds per minute. The weapon's nickname CIWS, pronounced CIWS, comes from the distinctive buzzing sound its spinning barrels create during firing. Phalanx operates completely independently of human control once activated. Its radar dome rotates constantly, scanning for incoming threats within a 5-mile radius. When hostile missiles enter the engagement zone, the system locks on and unleashes a stream of 20mm tungsten projectiles designed to shred incoming warheads. The Gatling cannon's rate of fire creates a wall of metal in the sky. Each tungsten round travels fast enough to penetrate missile casings and detonate warheads safely away from the ship. The system can engage multiple targets simultaneously, switching between threats and milliseconds as a computer brain prioritizes the most dangerous incoming missiles. Engagement ranges remain deliberately short to avoid hitting friendly aircraft or missiles. The phalanx fires only when enemy projectiles close to within 1 to 5 miles of protected vessel. At these distances, the system has mere seconds to identify, track, and destroy threats before they impact. Modern anti-ship missiles travel at speeds that compress engagement windows to almost nothing. A missile flying at Mach 3 covers a phalanx's maximum engagement range in less than 10 seconds. The automated system must detect, track, calculate, and fire without human intervention, relying entirely on computer processing power and mechanical precision. When ship-based offensives reach their limits, the ultimate response launches from carrier decks at supersonic speeds. But what happens when humanity's most advanced killing machines become too powerful for their creators to control? The flight deck of the USS Gerald R. Ford pulses with activity as red-shooted ordnance crews prepare the deadliest aircraft ever deployed at sea. F-35 Lightning II fighters sit lined up like sleeping predators, their stealth profiles designed to slip past enemy radar undetected. These fifth-generation fighter jets represent the pinnacle of airborne warfare technology. Each F-35 costs over $100 million and carries sensors capable of detecting threats from hundreds of miles away. The aircraft's stealth coating absorbs radar waves, making it nearly invisible to enemy tracking systems until weapons release. Advanced computer systems process battlefield information faster than human pilots can comprehend, turning each jet into a flying supercomputer armed with precision munitions. The ordnance crews work with mechanical precision, their bright red uniforms making them instantly recognizable on the busy carrier deck. These specialists handle weapons that could level city blocks, loading guided bombs and air-to-air missiles onto aircraft with practice efficiency. Each crew member trains for years to safely manage explosives powerful enough to sink enemy warships or destroy hardened military installations. Modern naval aviation operates on a scale that dwarfs previous generations of warfare. A single F-35 can carry multiple precision-guided munitions, each capable of striking targets with surgical accuracy from distances exceeding 100 miles. The jet's internal weapons bay conceals these deadly payloads from enemy sensors, maintaining stealth characteristics throughout combat missions. The loading process reveals the raw destructive potential these aircraft carry. Their guidance systems programmed to strike specific buildings or vehicles with pinpoint accuracy. Air-to-air missiles designed to destroy enemy fighters beyond visual range mount beneath the wings. Their seekers calibrated to track heat signatures or radar emissions. Flight operations begin before dawn as pilots prepare for missions that could reshape global conflicts. The F-35's helmet-mounted display system projects targeting information directly onto the pilot's visor, allowing weapon engagement without traditional cockpit instruments. This integration of human and machine creates unprecedented combat effectiveness, but also raises disturbing questions about the direction of modern warfare. As these advanced weapon systems become more capable, military planners acknowledge growing concerns about their ultimate implications. The F-35 program alone costs over $400 billion, representing the most expensive weapon system in human history. Nations worldwide scramble to develop countermeasures for aircraft that outclass previous fighter generations by enormous margins. The rapid pace of military technological advancement accelerates each year. Weapons that seemed impossible a decade ago now deploy operationally across global conflict zones. Artificial intelligence integration promises even more dramatic capabilities, with autonomous systems beginning to make targeting decisions without human oversight. Naval aviation crews witness this evolution firsthand as new weapons arrive faster than training programs can adapt. Missiles with ranges exceeding 200 miles allow single aircraft to engage multiple targets simultaneously. Electronic warfare systems can disable entire enemy communication networks from hundreds of miles away. The destructive potential concentrated on modern carrier decks equals the firepower of entire armies from previous wars. This exponential growth in military capability creates paradoxical situations where even the operators express unease about their tools. Veteran pilots describe weapons so advanced that they fundamentally alter the nature of aerial combat. The psychological impact extends beyond military personnel to civilian populations worldwide. Nations without access to fifth-generation fighters face obsolete air forces overnight. Regional power balances shift dramatically as advanced weapon systems concentrate in the hands of technological superpowers. International observers watch these developments with mounting anxiety, recognizing that weapons designed for deterrence may eventually prove too tempting to leave unused. The hope remains that such devastating capabilities will never face full operational deployment, but history suggests otherwise. Thanks for watching.